right? So this is in the form of p of x, y, that is cotangent x is p of x, and here is my q of x, right? So this is of this form. All right, so my integrating factor, in this case, let the integrating factor be e, the integrate px dx with respect to x. So this is e integrate cotangent x. Cotangent x is cos x over sine x dx. So you can see that the numerator is the derivative of the denominator. So the answer here is e to the power of natural log of sine x plus c, and we ignore the c. Therefore, the integrating factor itself is only sine x. So what now we do is to multiply the sine x to both sides of the equations. So this is what we're going to have: sine x dy dx plus sine x, and then here I have y cotangent, is that cotangent x is cos x sine x, and then equal to cos sine x cos x, right? And then what we need to do is to integrate both sides with respect to x. The answer to that is just going to be here's the derivative with respect to x of y, and here is the derivative of sine x. So here will be just y sine x is equal to, on the right hand side you can see that the cosine x is the derivative of sine x. Therefore, I'm going to have sine square x over 2 plus c. And then what I can do is to get y by itself, divide both sides by sine x. So it's sine x over 2 plus c over sine x. C over sine x itself is cosecant x. So c cosecant x. So that's the answer. Here we look at another example on how we're going to apply integrating factor to solve this particular problem. Here you can see that here is my p of x, and p of x in this case is actually 1. Here is my q of x. All right, so this is in that particular form, and I can use the integrating factor. The integrating factor here will be I of x with e integrate 1 dx. So that would be e to the power of x. That's the integrating factor. And we're going to multiply this integrating factor to both sides of the equation. Ex dy dx plus e to the power of x times y is equal to e to the power of x times e to the power of 2x. And integrate both sides with respect to x. All right. And here in the left hand side, you see this is a exact differential equation. So we are reduced to e to the power of x times y is equal to integration of e to the power of 3x dx. So integrate that will become e to the power of 3x over 3 plus c, right, x, y, and having y as the subject will means that this is e to the power of 2x over 3 plus c times e to the power of negative x. Here we have to use the initial problems, that is when x is equal to 0, y equal to 1, so that is use x equal to 0, y equal to 1. So 1 equal to e to the power of 2 times 0 over 3 plus c times e to the power of negative 0, which is 0. So this is 1 over 3 plus c. Therefore, c itself is 2/3. All right. And now I can write the full equation. The full equation is y is equal to 1/3 e to the power of 2x plus 2/3 times e to the power of negative x. So here's the answer.